Hey everyone, I'm Nick, and welcome to version 2 of C++ Crash Course. Now in this episode of the series, we're going to be talking about classes and structs in C++ and some of the small differences between them. So let's go ahead and get started first by looking at classes. So when we're talking about classes, we're really talking about these user-defined data types, and the same thing with structs. So we've already used classes in the past. They were just already made for us. So we've used std vector and say std struct. So these are all part of the C++ standard template library, but we may want to define our own classes and our own structs. So here we have, say, class wallet, right? So maybe we want to define our own class for keeping keeping track of, say, a wallet, and maybe the contents of the wallet in terms of dollars and cents, and maybe some other methods, say, for functions associated with these data members, right? So we may want to have this method for printing the contents of the wallet, for setting dollars and cents, and getting dollars and cents. And all of this ties back to this core tenet of object-oriented programming called encapsulation, where we're tying together the data and the methods or functions that modify this data. So one thing you might have noticed here, so we have these data members and we have these member functions or these methods. We also have these access specifiers, right? So we can say who's allowed to access, say, this data or these methods directly, right? So here with this private access specifier, we're saying that only other members of this class can access dollars and cents. And there's a small exception to this with friends of this class, but we'll get into friends later. But basically when we say private here, we're saying that only, say, these methods in this case can access dollars and cents or modify dollars and cents or get the value of dollars and cents. And when we say something like public, we're saying that anybody can access, say, these member functions. Now, your data members don't have to be private. They can also be public. So I could move, say, cents down here as well, and that's perfectly fine. A lot of times, though, we like to keep some of our data members private. The reason why is now we absolutely know who can modify dollars and cents. It can only be another member of this class. So I can define a really set interface, say with set dollars, set cents, get dollars, and get cents. And these are the only ways to modify dollars and cents or to get the value of dollars and cents. They have to be calling, say, these methods. And likewise, I can make, say, something like get dollars or get cents. I can make this a private method, which would mean that only other methods or other members of this function could call get dollars as well. So I don't just have to have public methods, I can have private methods as well. All right, so notice one thing here. I have this void print right here. So I have a method, say, for printing the value of the contents of the wallet, but I didn't define it within the class itself. So I can actually define methods externally of the class. And to do that, I just need to do something like this. So inside of the class, I say, hey, you're going to have a function that looks like this. So it has a return type, it has a name, and then it has a number of parameters. In this case, there's no parameters here, just because it's a print function. And here's the actual definition. So we've defined, we've actually put the definition externally. So a lot of times we call this a prototype, right? It basically tells the compiler, hey, you're going to have a function that looks like this, but you don't have the definition right now. So here we've got wallet : print, and this : again is the scope resolution operator. So we've seen this already, say, with cout. We've seen std cout, which says that this is cout from the std namespace. Now, likewise, this says I'm defining the print function, the print method, inside of the class wallet. So that's who this that's where this method belongs. And so inside of this print method, you see we're printing out dollars and cents, and this is okay, because this print method is a member of this class, so it can access these private data members or these private fields, right, of dollars and cents, right? And I don't need to say define dollars and cents because this belongs to wallet, right? So this print method already knows about dollars and cents because it belongs to this class, right? All right, so let's see a practical example of how to actually use this. So here, just like I would create a new instance of an int or a float or a double, I can create a new instance of my wallet. So here's my object, right? New instance of this class or struct would be an object. So we've got an object called Nick's wallet. And then here I'm using set dollars and set cents to set the value of dollars to 10 and set the value of cents to 37. Now again, to kind of hit home the point about these access specifiers, So here I've got, say, int dollars and or temp dollars and int temp cents, and I try to access dollars and cents directly. So this dot sign right here, this dot operator, this is actually accessing a member of this class. So I'm accessing a member function set dollars, and I'm accessing the member function set cents. And that's okay because these are public, right? So I can access them externally from this class. What I can't do is say access dollars directly or cents directly because this is private. So if I try to save this, see my linter will yell at me, and then if I try to compile, say, classes, it'll give me an error saying, error int wallet : dollars is private within this context, right? Or int wallet : cents is private within this context. So I can't access it directly. I have to go through, say, I would have to use something like get dollars or get cents instead. And then here you see I'm going to just call the member function print, right? And I'll print out the value of dollars and cents in a nice string. So first, let's go ahead and just compile this. So I'll just g++ classes.cpp-o classes. And then we can run it, and we see it just says the value of the wallet is 1037. All right. So another thing we can do is we can look at how do these member functions actually look inside of our code. So like we normally do when we're trying to understand what's going on at a low level for these things, let's use object dump. We'll use -d to disassemble classes, and we'll go ahead and just redirect the output to out.asm. We'll open out.asm, and let's go ahead and go to our main function first. There we go. We've oriented ourselves here. And now we can see I've got these function calls. I've got this call queue to this _zn6 wallet. So there's the name of my class, and then set dollars, right? So in reality, all of these member functions, they just look like normal function calls at the assembly level. So here, if I go up here to say wallet set dollars, you see I've got this simple function here for setting dollars. I've got another one for setting cents, and then I'll have another one around here for, say, print, right? So there's my wallet print function, and we can clear this up even more if we use name demangling. So if I use -dc using object dump, I'll get the name demangling. So let's go ahead and open up out.asm again. So now we see I've got this wallet : print, right? But it just looks like a normal function, right? It's kind of taken out of this class, and it just looks like a normal function call in the actual assembly. All right, so that's a little bit about the basics of classes. So let's get rid of classes and out.asm. So now let's go ahead and look at structs. And what's the difference between a class and a struct? Well, in reality, the differences are incredibly small. So here I have almost the exact same example. All I've done is I've replaced the word class with struct. And you see it looks exactly the same, right? The same methods, the same private data members, the same public data members. Even the main function is exactly the same. So if we go ahead and compile, say, structs instead, you see that the behavior is going to look very, very much the same. And then if I go ahead and do the same, object dump -dc on structs, and then redirect the output to out.asm and open up out.asm, orient myself to main, you see I've got these calls again to this, where it looks like the same thing. So I've got set wallet : set dollars, wallet : set cents, wallet : print. So what's really the difference here? These look the same at both the high level, kind of the C++ source code level, and then look kind of the same at the assembly level. Well, in C++, it really just comes down to these access specifiers. So what happens if I don't have private or public in here? What are these data members and member functions going to be, right? What's the default access specifier? And the only real difference between a class and a struct in C++ is that struct's default access specifier is public, and for a class, the default access specifier is private, right? So now if I go ahead and save this, and if we look down here, if I go ahead and get rid of int temp dollars and int temp cents, you see that I can actually compile this. So I compile structs.cpp, and it doesn't give me any issue, right? So I can actually access dollars and cents directly, right? Because the default access specifier is public. Okay, so what happens with classes? So now let's go back to our classes example. We'll open up classes.cpp, and I'll get rid of the access specifiers. And so for classes, the default access specifier is private. So if I go ahead and compile classes.cpp again, you see now I get a whole bunch of different errors now, right? Because now set dollars and set cents are going to be private methods, so I can't actually access them externally, right? So the only real difference between classes and structs is going to be the default access specifier. We can kind of use them interchangeably. All right, so that's going to be the basics of classes and structs in C++. There's more info to get into about things like the protected access specifier and when to use, say, public and private and protected. Other things in terms of the core tenets of object-oriented programming, like polymorphism as well. But we'll get into that in some later videos, as well as constructors. But that's going to do it for this time. As always, all this code is available at github.com/coffeebeforearch. So if we go here to C++ Crash Course, under Fundamental Concepts and under Objects, you can find this example for classes and structs in C++. So feel free to check these out, play around with them. Let me know if you have any questions. And as always, I'm Nick, and I hope you have a nice day.